This video will cover maths applied index laws. This is an extremely long video. I'll put some time tags in the description below so you can skip the question numbers. For this topic, we're going to need to be familiar with the index laws and comfy using them. So there are 6 rules that are generally used. They're not in any particular order here, although I have put that first one there because it tends to be a nice easy one to work with, and if I've got a hard question I tend to manipulate it to try and make it into a question that can be answered using this law. So let's look at that one first. If you're multiplying numbers that have got indices and the base number is the same, and it's very important that the base number is the same, what you can do is you can just add the indices together. So if we've got 2 cubed multiplied by 2 squared, then we'd end up with 2 to the power of 5. And if you'd like to see how that actually works, 2 cubed is 2 times 2 times 2, and 2 squared is 2 times itself. So here we've got 2 cubed times 2 squared, and there's 5 2's being multiplied by one another there, so really we've got 2 to the 5. In the second example, or in the second law, is when we're dividing. Now it's important again that the base numbers are the same, but if they are, we can just subtract the indices. So if we took 5 to the 5 divided by 5 to the power of 3, we would end up with 5 to the power of 2. And again, if you'd like to see how this works, we could take 5 times 5 times 5 times 5 times 5, so 5 to the power of 5, divide it by 5 times 5 times 5, so 5 to the power of 3, and we would see that 3 of those 5's are just going to cancel one another, and we'd be simplified to 5 squared, or 25. And the third example is when we've got brackets or parentheses, and in this case what we do is we multiply the indices. So if we had something like 3 to the power of 3, and that was squared, then we would end up with 3 to the power of 6. And a good example of this might be, well, if we want to have a look at it another way, we might have a look at it as 3 cubed. And if 3 cubed is multiplied by itself, then we'd be multiplying it by 3 cubed again. We've got 6, number 3 is being multiplied by one another there, so we've got 3 to the power of 6. So it's nice and clear to see how that's working. In the fourth example, we've got negative indices. A really common one is 2 to the power of minus 1. And this is just another way of writing a half. It's the inverse rule. And so here, if we take another example, because I think it's probably a good thing to name up here, if we take 3 to the power of minus 2, the answer to this one is 1 over 3 squared, or 1 over 9 if we simplify it. But it's important to notice here that it's the negative that makes it inverse, and the 2 goes down as part of the denominator as well. In the fifth law, we've got fractions. So if we, or fractions as indices, so if we take 8 to the half, this is really the same as writing the square root of 8. We might do another example here as well. So we'll do 5 to the 2/3, because we want to see where the numbers of the fraction go. This is equivalent to the cubic root of 5 squared, or the cubic root of 25 if we were to start to simplify that. And last of all, we've got the rule that anything to the power of 0 is 1. So it doesn't matter if it's 100 to the power of 0, that's also 1. Might be worth pausing the video for a moment and writing these laws down to help you in this topic. Now there's one more rule that, although you don't see it in this test preview, is great to keep in the back of your minds if you do methods next year, because you will see it next year. And unlike the other laws, if the base numbers are different, but the indices are the same, you can multiply the base numbers and the indices will remain constant. So if we choose an example like 2 squared multiplied by 3 squared, we'd end up with 2 times 3 is 6 to the power of 2, which we know is 36. And as proof that this works, if we think about it, 2 squared is 4, 3 squared is 9, and 4 9s are also 36. So that's just one to bank for later. Question 1's asking us to write these in index form, and here we can see that 4 is multiplied by itself 4 times. So what we've got here is 4 to the power of 4. In question B, we can see that 6 times 6 is there, so that's just 6 to the power of 2, or 6 squared. And it's no different when we've got letters. So in C here, we've got y multiplied by itself 3 times, so this is y to the power of 3. Questions 2 is asking us to evaluate, so we don't really need to solve it. We don't need to go through and simplify it. So all we really need to do is just write that this 2 to the power of 3 really means 2 times 2 times 2. In question B, we've got 3 to the power of 4, so that just means that it's 3 multiplied by itself 4 times. And in question C, we've got 10 to the power of 4, so it's just 10 multiplied by itself 4 times. And that's it. Question 3 asks us to simplify. So here, if we're dealing with numbers and no letters, we'll actually have to give an answer here. So 2 squared is 4, and 4 to the power of 3 is 64. And if we do 4 times 64, that will give us 256. But in question B, we've got x's. So here we go back to the first rule of indices. So when we're multiplying and the base number is the same, unlike in the first question here, where it was a 2 and a 4, it's an x and an x. So we simply add the indices. So it's x to the power of 7, 5 plus 2. In the second one, we're going to deal with the numbers first, and then we'll deal with the letters. We've got a 4 here, and there's a 1 here that we can't see. So 4 times 1 makes 4. We've got m's. We've got 3 here, and we've got an extra 1 here. There's a little 1 here. So we've got to the power of 4. And then we've got n to the 1 here, and n to the 5 there. So we've got to add those together, and we'll have n to the 6. Question 4 has got a mixture of questions in it. There's a nice simple one to kick us off here. When we do division, the base numbers are the same, they're both x. We just have to subtract the indices. So here I've got 5 minus 2 making x to the 3. But in the second question, you've got to be careful. There's no brackets here, okay? And that changes the question. Really, what this says is 16 times a to the 5 divide by 4 times a to the 3. And this is important because when we answer this, we've got the 16 divided by 4, which is 4. But the a's are multiplied. So we go back to the first index law and it becomes 5 plus 3 because of this times. So it becomes a to the 8. A similar thing happens in question C here, okay? Really what we've got is 12 times a to the 5 times b to the 3 divide by 3, and it only applies to the 3 times a to the 3 times b. So the answer is 12 divided by 3 makes 4, but we add the rest of the indices. We've got 5 and 3, which makes 8. And with the b's, we've got 3 and 1, which makes 4. Question 5 is where we've got brackets. And when we've got brackets, if you have a look back at the index laws, we have to multiply the indices in this case. So it is a to the power of 4 times 3, which is 12. Similarly, in the second one, we've got x to the 3, and then it's 3 times 5, so it becomes x to the 15. But question C, we have to be careful. There's a 3 inside the brackets that actually has a little 1 above it. So it becomes 3 to the power of 1 times 2. So that's 3 squared. And we've got a to the 4. So 4 times 2 becomes 8. And if we can simplify this, we will. And so we know 3 squared is 9, a to the 8. Question 6. we've got 9 to the power of 0, and we know that anything to the power of 0 is just 1. We have to be careful though, because in B, we've now got 4 times, funny looking times 1, because y to the 0 is 1, okay? So it becomes 4 times 1, which is 4. And then in C, this is one of these ones that we ran into back up here in question 4. We've got to be careful. We've got 21 divided by 7, which is 3. But remember, every other number here is multiplied. So it's a to the 5 times a to the 1, which is a to the 6 because we add them. And we've got a little x to the 5 on the end there. Question 7's got negative indices, okay? Now, the little minus, just the little minus, means inverse. That means we've got to flip it upside down, okay? So this one becomes 1 over 2 squared. Notice how the indice became positive when we moved it down. And if we can solve it, we will. So we know that 2 squared is 4. So this is the same as a quarter. In B, we've just got a negative 1 there, okay? So this becomes 1 over 6 to the power of 1. We just don't bother writing to the power of 1. And C, because it's brackets, that indice, that applies to both the 4 and the 5, okay? So in the first swoop, this becomes 4 to the power of negative 2 over 5 to the power of negative 2. But we don't usually write them with negative indices, okay? So I would flip this one upside down and make this 5 to the positive 2 over 4 to the positive 2. We'll talk about this a bit more later in this, but by moving the numbers or letters up or down, it influences whether the indice is positive or negative. In other words, it changes when you move it. And so here we can actually answer this, can't we? Because 5 squared is 25 and 4 squared is 16, and that's our final answer. The thing to watch in question 8 here is that it says that we have to answer without negative indices. So if we end up with any negative indices, we'll have to tidy that up. So we'll see how we go. In the first one, it's nice and simple. We've got a to the 6 times a to the negative 4. That means we just have to add those indices. So we've got a, and then 6 plus minus 4 is the same as saying 6 minus 4. So this one's just a to the 2. It's got positive indices, so we don't have to do anything about that. In the second one, we've got 8 divided by 4. Remember, everything else is multiplied, and I can't see any brackets there. So 8 divided by 4 is 2, and then we've got a to the 3 times a to the 5, which is a to the 8. And in the last one, we've got 2 to the power of 3, because there's a little 1 here we don't write, so 1 times 3 is 3. So we've got 2 to the power of 3. Y to the power of minus 2 times 3 is minus 6. Now this time we've got negative indices, okay? So what we'll have to do is we'll sort out what 2 to the power of 3 is first. That's 8. And then I'll send the y to the power of 6 down. And then everything's positive and we've answered the question. Question 9's got indices that are fractions, and probably the easiest way to think about this is that the top number of the fraction stays with the 36 and the 2 controls the root. Okay, so in the first case it'll be a square root, in question B it'll be a cubic root. So question A will be the square root of 36. In other words, which number multiplied by itself makes 36, and the answer to that is 6. So in the second one we've got that equals the cubic root of 64, which means which number multiplied by itself 3 times makes 64, which is 4. And if we've got the cubic root of 27, then the number that's multiplied by itself 3 times the make 27 is 3. Question 10, there's probably a lot of ways you can approach these questions, but I want to try and keep it as simple as I can. Here I'm going to deal with the numbers first. So I've got 4 times 5 that makes 20. I've got x's that are being multiplied by one another, and I know that the index law says I can just add those indices. So a half plus a half makes 1. Normally I wouldn't bother writing that in, so 20x is the most correct answer. In question B though, there's brackets. So I know that a half means the square root. So really what I've got here is I've got the square root of 64. And then instead of doing the square root of 8 to the n, I'm going to do 8 times a half, because half of 8 is 4. So I know that I've got n to the 4. And now if I can tidy it up, I will. The square root of 64, and that's a 6 by the way, is 8. And the n to the 4 stays. Similarly, if we have a look at question C, it's going to get a little bit uglier, but we can still do this. We have now got 100, the cubic root of 125, and it's a cubic root, so a little 3 goes there. And then we have got a, and what we've got to do here, and I'm just going to do this in orange so that it's obvious, I've got 8 times a third, okay? Now, it's hard to multiply fractions when they're not both fractions, so I'm going to make 8 a fraction, okay? And then remember, it just becomes a top times top, which over here, we're just going to make a little note, is an 8, and 1 times 3 is 3. So now what I've got, if I start my new line, is I've got the cubic root of 125, which is 5. In other words, 5 times 5 times 5 makes 125. A to the 8 over 3, okay? And remember that if we wanted to write this in a surd form, the other way that we could answer this would be 5 outside of the cubic root of a to the 8, okay? So we might just say that either of these answers would be appropriate, okay? In question 11, we're looking at scientific notation. Now, we would normally use scientific notation for really, really, really big numbers or really, really, really small numbers. We wouldn't normally use it for 282, but for the exercise, what we're going to do is we're going to make this 2.82 times 10, and then we're going to have a look at how many places the decimal has moved, okay? And it's 2, so we write it in. Similarly here, in question B, it will become 4.5 times 10 to the something, and we have a look at how many spots the decimal's moved. It's moved 1, 2, 3, 4. So a 4 goes in here. And in question C, it's going to be 3.97, and we've moved the decimal 1, 2, 3, 4, 5, 6, 7 places. So it's times 10 to the 7. Keep it at one number before the decimal. Don't make this 397 times 10 to the power of 5, for example, okay? Keep it as one number, then the decimal, and a couple of decimal places, times 10. That's the general conform that everyone follows. In question 12, we've got to go the other way, okay? So instead of writing it as a scientific notation, we're going to go in basic numeral. So we go the other way. This time it tells us it's a positive 2, so we're going to move the decimal 1, 2 places to the right and fill the rest in with zeros. So this will become 150. In the second example, we need to move the decimal 3 places. Okay, so we'll move 1, 2, 3. And so this one will become 3,231. In question C, we've got the decimal moving 7 places. So we go 1, 2, 3, 4, 5, 6, 7, and you might choose to fill all of these gaps in with zeros, okay? And so this becomes what, 4, 0, 5, 0, 0, 0, 0, 0, okay? Just to make that clear, I'll put some commas in. So this one's 40,500,000. Question 13 is an example where we've got a small number that we're writing as scientific notation. So this works the other way. We're going to have 5.6 times 10 to the negative something because it's small, okay? So the decimal is moving right, or if you prefer, the numbers are moving left, but the decimal's moved 2 places, so it's -2. In the second example, I've got 6.78. Remembering we're just doing one number before the decimal, and we're counting how many spots it's changing. 1, 2, 3, 4, 5. Whoops. So 5 spots to the right. And I'll lose my little half loop there. Okay, and then the last one, we've got just a nice straight 7 to the 1, 2, 3, -3. And in question 14, what we're doing is we're writing these scientific notations as a basic numeral. Straight away I can see that there's a negative number here, so it's going to be a small number. So this time I'm going to put my decimal to the 1, 2 to the left, okay? I'll fill in the gaps. The point will go there, so it will become 0.019, okay? So again, I'll do that again for you. This one's going to go 1, 2, 3, 4, 5. So we might fill in the blanks here. 1, 2, 3, 4 zeros. Then the decimal goes in, and there'd obviously be another 0 here. So this one's going to be 0.0000389. And last but not least, we'll move this one so it will go 3 to the left. 1, 2, 3. I'll fill in my blanks with zeros, put my decimal place in here, and I'll end up with 0.003007. Okay, we're into section B, question 1. Now, when we get into section B here, this is a blending of all the rules, so we don't get to just focus on one at a time. So my suggestion is that you simplify it, and if you can possibly turn the question into one that follows just rule number 1, it makes life much easier. So I'll show you what I mean by that. We know that this little 3 here, it applies to everything in the brackets. So now what we've got is we've got c to the 3, d to the 3, c to the 5, d to the 3. And I'm not bothering to put in any timeses because we know they're all in a row, so they're all being multiplied. Now all I need to do is go through and look at all the c's, and I've got this one here that's a 3, this one here that's a 5, so I've got c to the 8, and I've got d to the 3, d to the 3, so I've got d to the 6. I'm just adding the indices together. So question B, I've now got 3 to the 2, which is 9, got a to the 3 times 2, which is 6. I've got 10 to the 4, which is 10,000, and I've got a to the 5 times 4, which is 20. So I'll deal with the numbers. I've got 9 times 10,000, which is 90,000. And then I've got a to the 6 plus 20, so a to the 26. Question C. Okay, I'm just going to work across the row, and I'm going to get rid of the brackets as I go. I'm just ignoring the numbers at this stage. So I've got 2. I've got a to the 3, b to the 2, a to the 3, because there's a little 1 here, times 3, b to the 9, 3 times 3. I've got another 3 here, and a to the 4, and a b to the 3. Now, my strategy is deal with the numbers first. I've got 2 times 3, which is 6. Now I'm going through, I've got a to the 3, plus 3 is 6, plus 4 is 10, a to the 10. I've got b to the 2, plus 9 is 11, plus 3 is 14. Alright, and finally, the system's not changing here. They're looking uglier and uglier, but I'm just working across the row, getting rid of the brackets, and then I can simplify them down. So 4, a to the 3, b to the 4, 2 to the 3 is 8, a to the 3, b to the 9, 100, that's 10 squared, okay. A to the 6, b to the 1 times 2, which is 2. And now I'll deal with the numbers. Right, 4 times 8, which is 32, times 100 is 3200. A to the 3 plus 3 is 6, plus 6 is 12. B to the 4 plus 9 is 13, plus 2 is 15. And it's solved. For question 2, I'm going to suggest a different strategy. If you can get rid of that divide by sign here, let's do it, okay? So we want to try and make everything like rule number 1, where everything's just multiplied together. So what I can do here is remembering that there are no brackets here, okay? So we've dealt with this back in the first section. What we want to do is make that divided times. And the way to do it is I rewrite this row, but the c to the 2 becomes a c to the minus 2. And now I can just run across the row and just add the indices together. So it becomes c to the 6 plus minus 2, or in other words, 6 minus 2, which is 4. D to the 8 plus 5, which is 13. In the second one, though, they've thrown some brackets in, okay? So what we'll do is we'll just keep the brackets handy for a minute, okay? Because that means that that divide there applies to all of this, okay? So let's just bear with me a second. I'm going to keep the 3a to the 13, b to the 9. Going to keep the divide just for this line, and I know that that becomes 3 to the power of 3, which is 27, and a to the 3, and then this b to the 5 is still just times, it's just on the end there. And so what we'll do in the next line is the 27 has to go down, because it's really to the power of minus 1 there being divided, okay? So it goes down, so it stays positive, and we don't muck around with the numbers. And we'll just sort out the letters. So we've got a to the 13 minus 3, okay? Because it's being divided, so it's negative, so it becomes a to the 10. So it's 10 because it's 13, and this divided by here, you can see that, okay? That divided by makes this a negative number. That's why we sent the 27 down, okay? So a to the 10, and then the b's get added because they're just multiplied. So 9 plus 5 makes 14. We're not quite done yet. Unfortunately, I've run out of room, so I'm just going to swap colour just to satisfy this. We can simplify this fraction here, okay? So 3 over 27 is the same as 1 over 9. We won't worry about the 1. It'll just become a to the 10, b to the 14 over 9. Right. 2c. This one looks ugly, but we're not freaking out. We're just going to follow the same rule. In the first line, what I'm going to do is get rid of that, and I'm also going to get rid of these horrible brackets here, okay? So we're going to go across. We've got 36, d to the 5, e to the 11, f to the 14. I'm going to change the d to the 3 to a d to the minus 3, and that turns this into a times. Now I'll get rid of these brackets here, okay? So it's 3 squared, which is 9, e to the 6, because it's 3 times 2, 2 to the power of 3, which is 8, and then f to the 3. And now it's very manageable, okay? Now all I've got to do is 36 times 9 times 18. Sorry, I mean 36 times 9 times 8, which if I use a calculator is 2592. So 2592. And now what I'm doing is I'm just cleaning up my letters, okay? So I'm running across the row. We'll start with D. We've got 5 minus 2, 5 minus 3 is 2. E's, I've got 11 plus 6, so 17. And F's, I've got 14 plus 3, which is 17 as well. All right. Now, with question D, I'm going to show you a quick way, and then we get into the harder questions. I'll show you how to do this with a strategy that will always work, okay? So remembering that these ones, like D here, this is a great question because it's no longer like these ones that do have brackets or don't have brackets, and we don't know if we're timesing or dividing. It's everything here at the top divided by everything here at the bottom. So it's actually quite a bit easier, okay? So we go through and we just attack it. 16 divided by 4 is 4. Then it's d to the 5 divided by d to the 3. So it becomes 5 minus 3. So d to the 2. And then it becomes e to the 8 divided by e to the 4, which is just 8 minus 4. So e to the 4. Question 3, we're into some ever so slightly more complicated indices that are fractions. So we remember that 64 to the power of 1/3 is really the same as the cubic root of 64. So what number multiplied by itself 3 times makes 64? And the answer to that one is 4. Question B, you're probably going to want a calculator. Really what this is saying is, what is the cubic root of 27 squared? Now, 27 squared is 729, so it's the cubic root of 729, and the cubic root of 729 is 9. Question C, you're definitely going to want a calculator, but just for giggles, if we did this, what this would be is, and I'll go with blue because I've been using blue, this would be the cubic root of 125 to the power of 4. And that would be the cubic root of 244,140,625, which would be 625. But again, This is a good question for a calculator. And then this final one, D, if you actually just have a sticky beak at the one straight above it, there's a nice clue there for you. So remembering that the little negative symbol that you can see there is what makes the difference in this question. So this really is very similar to the one above. It's just that it's 1 over the cubic root of 27 squared, which we worked out the cubic root of 27 squared is 9, so the answer to this one is 1 over 9. I'll make that orange just so it's nice and clear. 1 over 9. Question 4. So in this instance, we'll still keep working vertically, and I'll show you another trick when we get into section A. So if you find this hard, it might actually be easier to skip to section A, and I'll show you an alternative for this one. But let's just do it the way that we've been running. So we're working top to bottom, and what I've got is I've got a 1 here that's not written. Okay, so we're going to acknowledge that just to start with. It'll disappear again soon. And I'm going to do the numbers first. I've got 1, and at the bottom I've got 4 times 3, which is 12. Getting the numbers out of the way and not moving them around sometimes helps. And now we'll work vertically. We've got a to the 5 and a to the 3, and we're dividing them, so we know we subtract them. So 5 minus 3 leaves us a to the 2. And then in the second instance, we've got b, which is to the 1, divided by b to the 4. And that leaves us with 1 minus 4, which is b to the minus 3. Now this question says simplify. It doesn't say that I need to answer it with positive indices. When we get into section A, you'll see that they do down here, but we don't have to worry about that yet. So we're just going to answer this as a to the 2, b to the negative 3, it's supposed to be a 3, all over 12. But if you want, you can answer this as positive indices, and that would look like this. So we can say, or you could answer it as a to the 2 over 12b to the 3. Some people prefer to make them all positive. Just be careful that the question doesn't say leave it as negative, okay, if necessary. All right, in the second one, we know that this guy outside the brackets here is going to impact everything inside, and it's going to multiply by them. So this one's going to become x to the negative 12 over y to the negative 8. And this is perfectly good answer, but if you like to put it into positives, we could flip this upside down, and it would equal y to the positive 8 over x to the positive 12. So we'll do the next one, and we'll find something similar, I think. We'll end up with a to the minus 5 times minus 2 makes 10 over b to the 3 times minus 2 makes minus 6. This is a perfectly good answer. Or if you want to make it positive, it will become a to the 10, and then we'll move the b up to make it positive. D. Now in this one's just gone back to nice simple working left to right. Everything's times, there's nothing tricky here. We've got x to the 4, and then we've got minus 3 plus minus 2. In other words, minus 3 minus 2, so y to the minus 5. Again, if you want to write it as a positive, you can. Doesn't say you can't. So this one would be x to the 4 over y to the 5 by sending it down. Both answers are correct. To tackle these questions in section A, I would be trying to get everything to look like the first index law. In other words, we really want to just be multiplying things and adding together the indices. So I'll do these ones one at a time. In 1a, I'm trying to get rid of the brackets. So I'm going to expand this out so that it becomes a to the negative 15, that's 5 times minus 3, b to the 5, a to the 4, b to the negative 6. And we have a quick glance up here, and the important thing is that it's told us that we need positive indices here, okay? So we're going to answer this one in positive index form. So as we collect them, if they're a positive number, well, first of all, we'll collect them up. So we've got minus 15 plus 4 leaves us a to the negative 11, and then we've got b to the 5 and b to the minus 6, which leaves us b to the minus 1, okay? Now, both of those are negative, and it tells us we need positive indices, so both of these need to go down to become positive, and that's a b to the 1. Section A, 1b. We want to make sure that this is nice and easy for us, and so we want to get this written out as if it was the first index law. So we want to get rid of those brackets, so everything's just multiplied. So we'll start writing 4a to the minus 3. The brackets didn't do anything in this instance. We've got a b to the 5, got the number 5, then we've got a to the minus 3 and b to the minus 3. Remember there's little ones here, okay, and they're getting multiplied by this negative 3. Okay, in the next line, we'll deal with the numbers first. We've got 4 times 5, which is 20, and then we've got a to the 3 and a to the 3, so minus 3 plus minus 3 makes minus 6. And then we've got b's, we've got 5, minus 3 makes 2. We've got to answer in positive indices, so anything that's positive stays up. So the 20 stays up, the b squared stays up, and a to the power of 6 goes down to become positive. There's a couple of ways to do question 1c, but this is a method that will absolutely always work. Okay, so we'll start by collecting up the numbers. I've got a 4 and a 3, so 4 times 3 is 12. And from here on in, I'm just going to work across in rows. And I'm allowed to do that in this question because it's all just multiply. So that times in the middle allows me to just work in rows. So we've got x to the minus 6, and that's minus 3 times 2. I've got y to the minus 5. I've got x to the 5 and y to the minus 6. And then down the bottom, I've got x to the 3 times 3, which is 9. I've got y to the minus 1 times 3, which is minus 3. I've got x to the minus 3, y to the minus 8. Now, there's a trick to this. Some people will like to collect these up and work up and down, but if you need a system that will work every single time, what we're going to do is get everything up in one row. We always leave the numbers where they are though. In this case, there's a 1 out here, so it's not going to make much difference. But we are going to get everything up in one row. So we've got x to the minus 6, y to the minus 5. I'm reading this from the top line. X to the 5, y to the minus 6. And then these numbers here are going to come up. So we've got x to the minus 9. It was a positive 9 here. Now it's become a negative because it's moved up. Y to the positive 3, x to the positive 3, and y to the positive 8. Okay. And now we've got the nice simple task of just sweeping through with rule number 1, adding the indices together. So we've got 12 and we've got x's, we've got minus 6 plus 5 makes minus 1, minus 1 plus minus 9 makes minus 10, minus 10 plus 3 makes minus 7, okay? And then I've got y's, I've got minus 5, minus 6 makes minus 11, minus 11 plus 3 makes minus 8, and minus 8 plus 8 makes 0. We have to answer this in positive index form, so everything that's positive stays up, the 12 stays up, and the y to the power of 0 is 1, so we don't have to write that one anymore, and x to the 7 goes down to become positive. Question 1D is asking us to divide fractions. So before we even think about index law, ignore that for a minute. I'm going to rewrite this question. And I'm going to do that by turning this divide into a times. And in order to do that, all I've got to do is flip this as it is upside down. Okay. So we'll start by doing that. We've still got a to the 5 over b to the 3. We're not changing anything yet, but we're making it times, and so the b to the minus 3 squared's coming up, and the a to the minus 12 is going down. Okay, now that it's times, it's much easier, and now we're entering into index law, okay? So we'll do the same thing we've been doing in the last few questions. We really want to get rid of those brackets. We want everything up in a line, and then it's nice and easy to solve. So what we have got is we've got a to the minus 15, b to the minus 6, all over b to the minus 9, a to the minus 12. I'll get everything up in one line, so I've got a to the minus 15, b to the minus 6, I'm bringing up b to the now positive 9 and the a now positive 12. And now all I have to do is just work across the row. So I've got I've got minus 15 plus 12 makes minus 3, and I've got b minus 6 plus 9 makes positive 3. And so to answer this in positive index form, anything positive stays up, which is the b to the 3. Anything negative goes down, which is a to the 3. Question 2 is an interesting question. What we've got is a couple of questions here where if we can make all of these numbers with a base number of 2, then they become quite easy. So what I've really got, if you have a look at that top question, is I've got 2 to the power of 3 times x, which is 3x, divided by 2 to the power of 12, and that equals 1, which could also be 2 to the power of 0. And so if I disregard the 2's now, and I just focus on the indices, I know that by index law, this is saying 3x minus 12, because when we divide, we subtract the indices, and that equals 0. And now what I've got is a nice, easy balance method question. So I am just going to add 12 to both sides, and I'll end up with 3x equals 12. And now I'll divide by 3 on both sides. This is nothing new. This is just the balance method, and I'm left with x being 4, and I've solved it. Question B, 2B, similar to 2A. So what we've got is we'll strip it out. I notice that everything's 3 to the power of something, so we can compare all of these, which is great. So we've got 3 to the 5x times 3 to the 2x all over, and I'll just make that little 2x orange so that it follows our colour theme. And then down the bottom we've got 3 to the power of 3, and that equals 3 to the 4. Now again, if we just disregard the 3's and we're just looking at the indices, we know that here they're being multiplied, So we just add those indices together. So really, if we start concentrating down here, we've got 5x plus 2x. And then that's divided by 3, which when we divide, we subtract indices. So minus 3 equals 4. And so we'll collect up our like terms. So I've got 5x's and 2x's make 7x's, minus 3 equals 4. And then we're just back to the balance method again. So we'll add 3 to both sides, and we'll find that 7x's equals 7. We'll divide by 7 on both sides, and x will be 1. I'm going to call this question 2C because it sort of went A, B again, and it'll get a bit confusing. So we're going to call them C and D. Question C is very similar to A and B. So if you haven't watched those, go back and watch that to make this make a bit more sense. But basically, what I want to try and avoid is I've got 3s here, and then I've got a 9 and a 1. So if I can make everything 3, then I can compare all the indices and I can apply the index laws to it. So I'll start this one by going 3 to the 2x times 3 to the x plus 1 all over 3 to the 4, and I'm going to turn this 9 here into a 3 squared, because I know that 3 squared is 9, so it's equal, it's equivalent. And I'm going to change the 1, this one here, into 3 to the power of 0, because 3 to the power of 0 is also 1. And so now I can ignore the 3's, and I can just go through and add these and subtract these, just using my normal index laws. So we'll go through and it will look like this. 2x plus x plus 1 minus 4 minus 2 equals nothing. I'll collect my like terms. So I've got 2x's and 1x making 3x's. And then I've got 1 minus 6, which is minus 5. And now I'll just switch over to the balance method. I'll add 5 to both sides. And I'll end up with 3x equaling 5. I'll divide by 3 on both sides, and I'll have x equals 5/3. Question 2, that we're now calling D, is similar to question C. Not all of these numbers here are 6's, so our first mission is to make them all 6's. So what we'll do is we'll change 36 into 6 squared, because we know 6 squared is 36, and we'll multiply that by 6 to the 2x. And then we've got 6 to the x plus 3, and we'll multiply that by 6 to the 3. 6 cubed is 216, and that equals 6 to the 4. Oops, and I'll just make these ones here orange, just so that it keeps up with our little system we've got going here. Now that the indices are nice and clear, we can just compare them. So when we're looking at the indices now, we know that we're going to add the top two, so it'll be 2 plus 2x And we'll have to subtract everything that's down the bottom because we're dividing by it. So we'll take an x, we'll take the 3, we'll take the 3 again, and that will equal 4. Collect up our like terms, and I'll end up with 1x. And then I'll have 2 minus 3 minus 3, or 2 minus 6. So it'll be x minus 4 equals 4. Back to the balance method. Add 4 to both sides. And x is 8. Section A, question 3, part A. Now, let's have a look at this one. First of all, let's get rid of the brackets. So we'll just, for the time being, leave the 32a to the half at the top. And down the bottom, let's get rid of those brackets. So it'll become a to the 4 times 2 is 8. And we'll have a to the 3/4 times 2, which is going to be 6/4 or 3/2. I want to get all of those up onto one line so that it's nice and easy to work with. So I'm going to leave the 32 at the top, a to the half still at the top. Then the a to the minus 8 comes up. It becomes a minus because it moves up. And I've got a to the minus 3 on 2. All right, now we're back to first index law. So I've got my 32, and then I've got a half plus minus 8 plus minus 1.5. So I'll have a to the minus 9. And it's probably going to want me to, it wants it in simplest form. So we could leave that as it is, or we could move it as a positive indice. Either answer would be fine in this case. So as a positive index form, it would look like this. So either of these two questions are fine, answers are fine. Question 3b, we want to get rid of those brackets and try and get it back to look like index law number 1 if possible, or if necessary. So let's just leave the 5, let's just write in blue. Let's just leave the 5, a to the negative 5 there, and we've got at the top here, we've got now a to the 2/3 times 6 would make 12/3 or 4, so we'll just write it as that. And then down the bottom, we've got a to the 3, and then we've got a to the 1 times 6, so a to the 6. All right, and then we like to bring everything up in one line so that we can just apply law number 1. So we'll have 5, a to the negative 5, a to the 4, a to the minus 3 when it comes up, a to the minus 6. I'll have 5, a to the minus 5, plus 4 is minus 1, minus 1, minus 3 is minus 4, minus 4, minus 6 is minus 10. If you like to write that in positive index form, it will look like this, but the question hasn't asked for it, so either form is fine as your answer. Another way to think about question 4a is to rewrite it. So if we take our 27, x to the 9, y to the 3, and we pop it in brackets, it would have an indice of a third. And now we can just apply the index law where we multiply indices where there's brackets. So we know that the cubic root of 27 is 3, because 3 times 3 times 3 is 27. 9 times a third is 3. And for the y's, 3 times a third is 1. So you can just say as the answer like that. Question 4b, we've got the same index law as in 4a. So we've got brackets. So we'll get rid of them. So we've got a to the 5 times minus 2, which is minus 10. b to the minus 3 times minus 2, which is positive 6, all over a to the negative 3 times negative 2, which is positive 6, and b to the 4 times negative 2, which is negative 8. We like to get them all up in one row, so we've got a to the minus 10, b to the 6, a to the minus 6, b to the positive 8, and then as we run across the row, we've got minus 10 minus 6, which is minus 16, and we've got b to the 6 plus 8, which is 14. The question doesn't specify that we have to answer in positive index form, so that answer's fine, or we can keep the positive at the top and send the negative down, and everything will be positive. So either answer's fine.